All right. Hello, 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 everybody. Hello. Actually, I'm gonna need to go back to this for a second. Woo! Hello, 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 everybody. Sorry for the late start. Sorry for the late start. Sorry for the late start. I apologize so profusely. Hello, hello, hello. Okay, let's do this. Right. Hello, hello, hello. Oh, let's do that right. Oh, oh. Okay. Apologies for the slightly late start here. Well, actually, late start period. Let's do this here. Hey, Beth, how are you? Shah, how are you? Rihanna, hello, how are you? How's everybody doing tonight? How's everybody doing? Really, really well, I hope. Ujwal, hello, hello. How are you doing tonight? How we doing? Hope you're doing well on this fine Wednesday evening. Hello, hey, how's it going? You good? Good? Pretty good, Mr. Hey, Ballad, how you doing? Castro, I hope you're doing great. You doing really good? Hello, Natty. How's it going? Everybody's coming out here. All right, I'm happy. Sorry for the late start, everybody. I do very duly apologize here. Got into a nice debate with somebody. Not well, at least not really debate, but just talking things out on another stream there. So it was just pretty fascinating. You get kind of wrapped up into it sometimes. But much love, much respect, much good things. Natty, I'm doing really well. Drunken Lover, hello. How are you? Hey, Susan, how are you doing? Are we doing good? How we doing this fine evening? It's really smooth when you just kind of move your hand like this. You're like, fine. Susanna, hey Susanna, how are you? I hope you're doing really well. You doing good? Good. Good. Rocket Lover, good. Glad you're doing really, really well. Doing really, really good today. We're all on the positivity train today. Lots of positive vibes here today, I'm sure. Sure you guys are doing really well hopefully tonight. Got a little bit of food in maybe, or maybe just got off of work. Either way, I just hope that things went well today on this glorious Wednesday / hump day. So it's hump day. Okay, so we'll wait for a few more people to come in. We got a lot of people coming in. All right, this is good. This is good. And apologies for the late start here today, ladies and gentlemen. Ladies and gentlemen, I have banana milk. All right, today is banana milk day. Okay, so I just felt like banana milk for this class. So yeah, it's a necessary need to get banana milk in your life. All right, this is the most important part here. Got to shake it up a little bit, Okay, so tastes like absolute victory. Absolute victory, ladies and gentlemen. All right, we hopefully we're all ready to go here. Getting a little slightly bit of a late start, but no problem. All right. Okay, oops. I pushed the wrong thing. Yay. All right. Well, let's go ahead and get going here. And we're going to go ahead and see what's going to happen today. Got some important things we certainly have to do, so let's go ahead and get rolling here. All right. Let's do it. Intro time. Okay, let's get started today. Welcome back to Wednesday, end of the week time today. So today, we're going to pick up where we left off last time. Last time, we talked about how to find standard deviation using a calculator. And you're like, whoa, standard deviation using a calculator? And I'm like, yeah, standard deviation using a calculadora. Indeed. All right. So today we're going to pick up from just that spot there, and we're going to talk more about where standard deviation kind of fits in. Okay, so it fits in again. Standard deviation is used everywhere in statistics, so definitely has a lot of applicable uses. But we're gonna look at the first applicable use here. So let's go. Let us go to the big board here today. The big board here. Let's go right here. Bye bye. All right, here we are at the big board. All right, so we are going to start here on question number 10 from the last handout here. Why am I zooming out? That was not the intention. It was to zoom in. That was the intention. Yes. Ladies and gentlemen, I don't know what I'm doing, but somehow I made it here. All right, we're just saying. Alrighty. We're gonna make it. All right. That's the plan. You guys tell me what I'm doing, then I'll know what I'm doing. All right. Okay. So let's go to question number 10 here for today. All right. So question 10 states, what is the 68, 95, 99.7 rule? Okay. Well, let's discuss about that here. Now, the 68, 95, 99.7 rule is based on the normal distribution. And we talked about the normal distribution here previously. The normal distribution was our bell-shaped curve that we had discussed last time. So we looked at, say, a perfectly symmetrical kind of a histogram, or again, a perfectly symmetrical bell-shaped curve. Again, we can cut it down the middle. We're going to have a 50% on one side, 50% on the other side. So if we look at it from, let's just look at it from a pictorial representation, just looking at it from a picture, and we'll talk about what this rule actually means here using what we have discussed from before. All right. Okay, so let's go ahead and put in a curve here. So what's our curve going to look like? A bell-shaped curve is going to look something approximately akin to this. So here's a bell-shaped curve. It's not, of course, the prettiest thing in the whole world, but there you go. Okay, and what we can do here with this bell-shaped curve is that we can cut it right down the middle, like a slice of cake. Cake. So what we have here is we have a perfectly symmetrical shape. All right, we have 50% technically is going to be on the left-hand side of that dotted line, and 50% is on the right-hand side of that dotted line. Now, what is important here is, of course, what this middle ground represents. What this middle ground represents here is this represents the mean. Okay, so this represents the mean here. All right, cut right down the middle here. We're going to start from the mean and fan our way out. So, what exactly does that mean? Aha, bad puns. All right, we're going to go one off to the right of the mean. I'm going to draw this purple line here. That's a little bit off to the right. We'll draw a purple line here off to the left, just like so. Now the question is, what do these purple lines represent? Well, if we go to the right of the mean here, this is basically going to be the mean plus one standard deviation. If we go to the left, this represents mean minus one standard deviation. Okay. All right. So how does this factor into the actual question here on the handout? Well, how does it factor here? Well, again, let's take a look. It says, what is the 68, 95, 99.7 rule? Well, where exactly does this come into play? These numbers. Where is this? What does that actually matter? Well, let's take a look at the first number here. 68 represents, each one of those numbers here actually will represent a percentage. What does that percentage mean? Well, let's see. All right, so basically what this says is that, let me shorten that up a bit. So this basically says 68% of all data items in the data set are within one standard deviation of the mean. That's what the 68 represents, all right? 68% of all data items in the data set are within one standard deviation of the mean. All right. Okay. All right. Let's take a look at the next one here. Maybe I'll draw some black lines here. All right. And maybe here we have plus 2 standard deviations. Maybe over here we have minus 2 standard deviations. And so what does this black line to this black line represent? These two black lines represent, again, 95%. So we could say here, again, how do we conclude with this? We say, okay, well, 95% of all data items in the data set are within 2 standard deviations of the mean. Okay, so so 95% of all data items in the data set are within 2 standard deviations of the mean. Okay, and let's take another line here. Make it red. Make one here. Make one here. So in red here, we're going to have plus 3 standard deviations. And here we'll have minus 3 standard deviations. All right. So we have that. Okay. So, of course, if we look from red line to red line, this represents 99.7% of all data items in a data set fall within 3 standard deviations of the mean. Now, again, what does that exactly mean here in this case? Well, again, this is underneath a normal distribution. So, again, a normal distribution is a very predictive pattern here at the end of the day. Okay, very, very predictable. All right, there's nothing wrong with a predictable pattern, but this is the predictable pattern that we get here in this particular instance. Okay, now the predictableness is actually even better because we're underneath the easiest condition possible, the normal distribution. Remember, as we stated here last time, we talked about a normal distribution or the bell-shaped curve, we said that it was symmetric. And because it's symmetric, then that means that the percentages here are also going to also follow the same set of symmetry. So if you take a look here, 68% of all data items are within 1 standard deviation of the mean. Well, we're going to have the same percentage on the left as we are going to have on the right. So we're going to take 68 divided by 2. And so in this first bar box, we're going to have 34% over here and 34% over here. So half and half, exactly half and half. Next, we have 95%. So we have 95% here. We have 95 minus 68. That's 27. 27 divided by 2 is going to be 13 and a half. So we get 13.5. Next, we have 99.7 minus 95. That's going to be 4.7%. We'll divide that by 2. So in the next 2 bars here, they have to be symmetric. They have to be exactly the same values. We get 2.35%. Finally, we have the last 0.3% to represent the rest of the data set. So we take 0.3%, which is again 100 minus 99.7, and then we cut that in half. So our last values here are going to be 0.15%. Okay. Are there any questions about that before we move forward? We're going to do an example using this, but any questions so far? How did I get that last number? So that last number there, yes. So I took 100% because Natty, I still have to represent the entirety of the data set. So I've represented 99.7% between the two lines. But I need the extra 0.3% that I'm missing here that would be beyond 3 standard deviations. So I take 0.3, so I do, again, the 100 here, minus 99.7. That's going to be 0.3. Then I divide that by 2 because of symmetry. So I get 0.15 as a result. So that's where I come up with that value there. I assure you that didn't come out of nowhere. Oh, sorry, Natty. My bad. Let me switch cameras then. Boop. I'll take out my face. Hey, there you go. You're like, I didn't have to look at your face anyway. You were too ugly. So I'm just going to force you to do it. I'm like, okay, that's fine. Hey, Taylor. Want to end class early? No. No. I can't end class early. No. I'm not about to deprive these very wonderful people for coming out and doing some statistics. That and they're going to have a test on it eventually, and they're going to kill me if they don't do anything. Of course, of course. Ask me about anything. Anybody can ask me about whatever. It's all good. All right, cool. Any other questions before we move forward? Can I go over how to get 13F? Sure. Again, so the first two bars here represent 68%. Okay. So then I know that based on the rule here, the between the black lines represent 95% of the data set. So again, I took 95 minus 68, which is 27. And I took that 27 divided by 2 because of symmetry, because they have to be the same percentage in each bar. So I do 13 and a half. That's how I got 13 and a half. That's how I did it for every single bar here. They have to be the same for every single bar because of symmetry. So this bar has to equal this one has to equal this one has to equal this one, and this one has to equal this one. You need a perfect 50-50 split right from the mean if we're going to maintain symmetry in a normal distribution. Any other questions before we move forward? No problem. You know I'm here to help. You know it's all chill. Yes, because of the symmetry of the normal distribution. That's correct. Normal distribution is the most predictive pattern. And here's the nicest part, Natty, in relation to that question. Because it's a normal distribution, these are pretty much set in stone. Okay? If it's a normal distribution, these percentages are pretty much set in stone. If it follows a normal distribution. So that's what makes it really, really nice is that these guys here very predictable, and so are these percentages. It's exactly as you see it. That's why I draw out this picture here to hopefully put a little bit more visual representation for it. And let's take it a step further. Actually, I think we need to take it one step further than that, though. Okay, let's take it another step further. We're gonna up our game here just a bit. All right. So upping our game here means we're gonna have to answer some questions using this chart here. So let's go ahead and do that. So let's go with an example here, and let's say that we're given the mean and standard deviation. All right. So let's say we want the mean and standard deviation. So let's say we're just picking some easy numbers, okay, simple numbers here. So let's say the mean here is 10, and let's say the standard deviation here is 2. Okay. Mean is 10, and the standard deviation here is 2. Okay, so really nice, easy numbers here. Okay. All right. So let's follow this logic here about this. So right here, smack dab in the middle, okay, the mean here is given to us as 10. All right. So everybody can agree that's exactly what's given to us here. Photo, thanks for the follow, my friend. All right. So let's go ahead and take a look here at this line right here. We have the mean plus 1 standard deviation. So if this is the mean plus 1 standard deviation, what would we have here as our next value? What would be the mean plus 1 standard deviation be based on our mean being 10 and our standard deviation being 2? What number should I have here? What do you guys think? Mean plus 1 standard deviation. 12. That's correct. That's right. So we're going to have 12 there. Absolutely spot on. All right. How about the next one over? Oh, it's plus 2 standard deviations. What should I have next to that? What's plus 2 standard deviations here? Should I have in that spot? So I have 10, 12. I have plus 2 standard deviations. 14, that's right. I should have 14 in that spot. And if I go one more over here, 3 standard deviations will be 16. Okay, so 10 is with this, 12 is with this, 14 is with this, and 16 is right here. Okay? How about we go left? If we subtract by 1 standard deviation, right? So I'll bring up the camera here again. All right, so if we have minus 1 standard deviation here, what should I have here off to the left of 10? If we go minus 1 standard deviation. 8, that's right. Nice job, camera. How about minus 2 standard deviations? What should I have there? 6, okay. Good. Nice, nice. Okay, you guys are starting to get it now. That's good. All right, and then the next one here is 4. So again, you can see the pattern start to emerge about how I came up with these numbers here. All I did was add 2 every single time down to the right and subtract 2 every single time down to the left of the mean. Okay, because that's our defined standard deviation, at least in this particular example. Now, the questions that could arise here from this particular rule come down to this. Let's go ahead and type in our question here. The question could be is what percentage of data items. Yusuf, how are you doing? My day is going well. How about yours? What percentage of data items are below 6? Let's go below 8. Actually, no, let's go above 8. Let's go above 8. Let's just go with that. I think let's start with something a little easier. Okay. So what percentage of data items are above 8? Okay, so let's go with that. So all we need to do here is if we're going to look at the percentage of data items that are above 8, according to this example, let's look at the visual representation here. 8 is underneath this purple line right here. So notice the words here, the wording here is very important. Good, good. The wording here is very important. We want to look at above 8. So we're going to look at this purple line, and we're going to look all of those percentages to the right of that first purple line. So we're going to look at 34, 34, 13 and a half, 2.35, and 0.15. Just going to add those up together. That's correct, Ujwal. Absolutely correct. 100%. That is the correct answer there, Ujwal. But I'm just going to write in the work here just to hopefully make it clear about where we justify that answer from. And you got it. Nice. 84%. Spot on. Okay, good. So far, so good. Let's take a look at a couple more questions here. Okay, let's talk about below. Yeah, let's do the second one. I wanted to do an easy one here first. This is slightly a bit tougher here, but how about below 6? How about below 6? What percentage of data items are below 6? 2.5%. Okay, that's right. So 6 is right here, this black line. We want below that value. We're going to take 2.35 plus 0.15. Okay, so that's right. All right, very nice. Good job, good job. Let's try one more. How about between 12 and 16? look at between 12 and 16. What would be the answer to that one? So the percentage of data items between 12 and 16. Here. 16%. Okay. 16. 2.35? Not quite. This is a good. I like these answers though. I understand. If you're confused, that's not a problem. That's why we're doing this. All right, so let's you know what I think let's do a little bit of a poll here. I think that's fine here. So we got 16, we got 2.35, we got 2.5, we got 15.85. All right, and let's just put yeah, let's just go with that. All right, so there's a poll up there. Let's do the poll. Which ones do you guys think? There's got 4 choices there. The poll's up top and the top of the chat there. You guys can decide which one you believe to be the answer. Okay. All right. Got like 15 seconds here. Anybody else want to vote in the poll up top? On top of the chat there. They may feel free to do so. All right. So it looks like majority says 15.85. And the answer is going to be, that is the correct answer, 15.85. So let's take a look about why that is. Okay? Let's take a good look. So the reason why that is that 12 is right here, this purple line. Okay? So we want between 12 and 16. So 12 is this purple line, and 16 is this red line right here. So all the percentages between the purple line and the red line are only these two guys right here. Okay? Which is 13.5 and 2.35. So in fact, when you look at those two guys there and put it together, that's where you get for 15.85%. And that's your final answer for that. Any questions about that? Make sure that that's hopefully clear about where we came up with that. Hey. Okay, makes sense. Good. Don't worry about that, Natty. Why do we add? Again, take a look here. 12 is the purple line here. 12 is the purple line here, and 16 is the red line here. So the percentages between the purple line and the red line here is going to be 13.5 and 2.35. What do these percentages show in a study? Well, if it followed a normal distribution in a study here, yes, it is because of the wording here, because we say between, right? Right, you added the 0.15, but that's not between. That's actually outside. But yeah, got to be a little careful about that. So okay, so go back to your question there, Ujwal. What do these percentages show in a study? So essentially, if our study showed a normal distribution pattern, and this is the study that we got here with the mean of 10 and a standard deviation of 2, for example, that would mean that 15.85% of data items are between the values of 12 and 16. Okay, that's essentially what it would actually tell you. Is that underneath a normal distribution, if it follows a normal distribution, you should expect 15.85% of the data items in any given data set to be between those two particular values, in this case, 12 and 16. So I hope that makes sense there. Any other questions? Any other questions today? No problem. I'm here to help, okay? Ask away. I hope that answered your question there, Ujwal, by the way, as well. So is this how they get those numbers of success or fail rate for something? Ah, that's a little bit different, Ujwal. That's a little bit different. We will actually look at that. That's more of a probability, more so of things. This is basically looking at it from a more macro perspective. But success or failure is a little bit of a different story because that's dependent on probability. So we're going to actually look at that here in more detail in future chapters. So look forward to that. That will definitely come when we reach chapter 5. So what would it be if it was between 6 and 8? So between 6 and 8 here, 6 is the black line right here. 8 is going to be the purple line right here. So between 6 and 8, we only have the one value here, 13.5%. So the answer here, camera, would be 13.5. Black line here for 6, purple line here for 8. And the only percentage between those two numbers is the 13.5 that we see there on the picture. That's why I put it as a picture here, because it's a lot easier to visualize between what values that we have here in this instance. Yeah, you got to pay with attention which, yes, that is correct. That's correct, camera. That's right. That's correct. If you had told me, your answer would be correct at 2.35 if you told me between 4 and 6 and not 6 and 8. That's where you got to be a little bit extra careful. That's right. Hey, we're smoothing out the wrinkles here. That's all good. That's all good. It can be tricky, but that's why we're looking at it from a slightly different perspective. Okay, now, we do need to move on here to the next question. But let me preface it by saying this. The normal distribution that we see here, our bell-shaped curve, is a very unique case, okay? A very unique distribution because it has it has symmetric properties and whatnot. But a lot of different other types of distributions could work very differently, such as what we saw before. We saw a skewed left, skewed right distribution, or heck, a distribution that's kind of all over the place. We can certainly have that there as well. So how do we boil down a generic case as opposed to a very special case like the normal distribution? Well, let's take a look at the next question here on the handout. And that talks about Chebyshev's inequality. All right, so Chebyshev's inequality is just basically another way of stating what's the number of percentage of data items that lie within some amount of standard deviations above the mean for a generic distribution. So this is more of a generic distribution rather than the normal distribution. So for a generic distribution, not normal distribution. Okay. So it's not going to match exactly the normal. It's not going to match the normal distribution, not by a long shot. But let's go ahead and read this off here. So it says for any data set or distribution, at least 1 minus 1 over k squared times 100% of the observations lie within k standard deviations of the mean, where k is any number greater than 1, i.e. k bigger than 1. So again, and if we picked 2 here, it says, okay, well, what's the percentage of data items are within 2 standard deviations of the mean? Well, back to our paint tool here for a second. If we followed the Chebyshev's inequality, we would do, let's say k is equal to 2. I would do 1 minus 1 over 2 squared. All right. And then times that by 100, of course. So then I get 1 minus 1/4. And then I would get 0.75. If you just do that on the calculator, you can do that out. Or again, I could clearly say underneath Chebyshev's inequality, I could say that 75% of all data items in the data set fall within 2 standard deviations of the mean for any given distribution. Okay, so this is not something we're going to focus on too hard here, but again, this is for generic distributions only. So most of the time here in this course anyway, we're going to be dealing with we're going to try and deal with the ideal case here of the normal distribution. We just have to kind of maneuver things around a little bit in order to make it a bit easier to work with. So we'll see exactly how that works out once we get to more of the probability side, but at least you see a little bit of a preview. Again, how it worked from the previous question, or again, how it worked from a generic perspective as well. Yeah, all right. So, all righty. Okay. Any questions about that? Any questions at all? Sure. There you are. I'll go ahead and leave it up there for, nope. Now remember, if you miss anything here today, that's okay. Again, these replays will be available to you should you need to go back and take a look at them. So again, the replays there, I'll be going over a lot of kind of information here today. So yeah, it's just going to be one of those things. All right, I'm going to move forward here. Is that okay? Everybody good? All right. Okay, cool. All right. Let's move forward here. Yeah, no problem. What I'm here to do. Here to help. All right. So, let's take a good look here at the next handout. Okay. Yes. I'm going to save this. Okay. I'm going to go to the next handout here. All right. Now, you don't have to write this down per se. There are a few things that we'll talk about here in terms of approximate mean and standard deviation and whatnot. We're going to basically do both questions 1 and 2 using the calculator here. This is basically, if we're going to approximate the mean here of group data. Now, here's the difference. This is for grouped data, okay? Now, what it means by group data is basically saying, okay, what if I gave you a frequency distribution right off the bat, and I said, okay, can you find the mean of this frequency distribution? Okay, so I guess one of the things that I do need to make note of here, specifically, is that note here, let's put some bold here, note, this is used if given a frequency distribution, but no specific data set. Let's say you don't have the actual values, but you have the breakdown of those values. Okay, so based on a frequency distribution. So the problem with that is that, again, let's say we had like the number of test scores here. So let's put up an example here. Okay, so I'm going to put up an example here in the Paint tool once again. Let's not save. Oh, that didn't get rid of it. All right, now we can go. Okay, so let's put up an example here in this instance. So let's say, for example, we have our same frequency, we have a frequency distribution of test scores once again. We have the same categories as once what we had before, our same classes, right? Let's say we have, again, let's go 50 to 59, right? 60 to 69, 70 to 79, 80 to 89, let's say 90 to 99. And let's say we have a frequency for this. This time, though, instead of just giving you the list of scores like we did before when we first went ahead and said, okay, let's arrange this data into like a stem and leaf plot or histogram or whatever, I just give you the frequencies from straight up. So I say, okay, there's 4 here, there's 7 here, there's 6 here, there's 11 here, and then there's 8 here. Okay, so let's say this is our particular distribution here for this particular data set. All right. Now, the problem is, like I said, we have this frequency distribution, but no actual data items of which to actually use to say finding the mean or finding the standard deviation. If we had those, we could do the same thing that we did before last time. So unfortunately, we're kind of out of luck there in this particular instance. Instead, what we do is we go ahead and use, and more importantly, what's the most important thing here? We use the midpoint of the class. So notice here, how do we find the population mean or sample mean? We have to find the class midpoint. And the class midpoint here uses the lower class limit of class 2 and the lower class limit of class number 1. So if we look back at our example here, let's take a look at our example here. And so if I wanted to say, okay, can you tell me what the midpoint is going to be for each one of these particular classes? Well, class 1 and class 2 are something that we had discussed from before. Again, class number 2 is, again, the category or class that is directly after the class before it. So this would be, say, class number 2 would be like the 60. I'd add that to the 50, and then I divide that by 2. Again, I take both the lower class limits there. And then if I do that, then I end up with 55. I'll try the same thing now. This time, my class number 2 will be the next one over, so I get 70 plus 60 divided by 2. So here we get 65. Next, we have, again, 80 and 70, so we get 80 plus 70 divided by 2. That equals 75. Now you can see a pattern emerging, but I'll show you one other thing here in just a second. You get 90 plus 80. So divide by 2. We get 85 right here. And then finally, 90. Technically, there's no category or class after 90, but just imagine if there was, it would start with 100. So if there was one, it would start with 100 here. That would be our lower class limit for the class next up. Again, that goes back to the fact that we talked about here is that every class, every class has to be consistent. So every class width has to be consistent. So as a result, that's what we would start with. So, and our midpoint here would be 95. Okay. Now you're taking a look there and you're like, oh my goodness, that looks terrible. Holy smokes. How do I, look at all those formulas. How do we even get that? How do we get the mean here? How do we get the standard deviation? Like I said, these look very complicated and whatnot in terms of the formulas and the letters and all that 10,000 yards here. I assure you it's not. Now, you're not going to have to, again, memorize these at all. What we are going to do, though, is we're going to take our example here and we're going to work with the calculator here to actually find both the group data mean, and we're also going to go ahead and find the standard deviation. Now, one of the things that I did here, because the midpoint here is part of the formula, notice this is our step here that you have to do. You have to find the midpoint here. Okay, so remember, find the midpoint here. Let's put down as a note here because that's worth it. So, a note, find the midpoint of each class first before using the calculator. Okay, I'm just going to point that out here. You're going to find the midpoint of each class first before using the calculator. All right. We need to have those numbers in place so we can go ahead and plug some stuff in. Okay. Let's go to the calculator now and let's see what we're working with. Where are you, TI? Here you are. Okay. Okay, so here's our calculator right here. All right. So what we're going to do here is, again, if you have your calculator out, we're going to go ahead and hit the stat key here. And we're going to go to edit here once again. Now, you may have values here in your first list, in list L1, as you see up here on the screen. If you do see values there in list 1, we want to clear that list out. Now, to do that, we're going to hit the up key here. We're going to highlight L1, hit the clear key, do not hit the delete key, hit the clear key, and hit enter. All right, do not hit delete. If you hit delete, you'll have to hard reset your calculator. That's no bueno. All right. Now we're going to go ahead and enter in values here into list number 1. So again, hit the stat key and go to number 1 here that says edit and hit enter. And you'll get to your lists there, camera. Any other questions before we move on? We're going to get ready to enter in some data. All right. So what we're going to do next here is we're going to go ahead and we're going to enter in the midpoints here for all in list number 1. So we're going to put in the midpoints here. We'll put in, again, the first one here, we're going to go ahead and put in 55. We'll put 65, 75, 85, and 95. So those are the 5 numbers. Those represent the midpoints here of every class. Okay? Okay. Let's take a good look here at the list number 2. Now in list number 2 here, we're going to scroll over to list number 2. In list number 2, we're going to put in the frequencies we have here. So I just randomly chose these numbers here, but we're going to put in exactly the frequencies that we see here in this list. Okay. All right. Now, we have our numbers that we want here in this instance, so that's okay. So we're going to hit second, end mode. We'll quit to the main screen. Again, this makes sure that we don't enter in any other bad numbers in here. So we want to make sure that we keep on top of things there. All right. And we're going to go back and hit the stat key here once again. This time, we're going to go over to the calc menu one more time. We're once again going to go over to 1var stats. So we're going to use 1var stats here. I'll go ahead and enter in just a second. Now, this time though, in this instance, let's take a look at our little submenu here. In our little submenu, we have the first list which says L1. That part is true. We're going to leave that alone here. How do I get to that calculator? Do you have the TI-83, TI-84? I'm using software that I got from the college there. However, if you have a TI-83 or 84, you can get that. Or I was discussing this earlier today. So here. You can rent from the bookstore there, or that's not what I'm. Okay. If you have the 84, I'm doing the same exact thing as you would on your regular calculator. You can get the calculator here. It's just going to be a like a 90-day free trial or something like that. So you'll only have a limited amount of use, but yeah, unless you buy a license for it. But you can get a 90-day free trial. So if you want to roll with that, you can roll with that. Yeah, your choice at the end of the day. So okay, cool. All right. Now, in this next part here, we're going to go down to frequency list here. Let's go to frequency list. And this time we do want to use a frequency list here. We're going to go ahead and hit second and 2 because our frequency list should be list number 2 that we put here in the calculator. And then we're going to go ahead and hit calculate. Now, if you have an old school calculator here, let's point this out here. What you want to put in next is you want it to make it look like L1, comma, L2. So if you have the old school calculator here, this is what you need to have on the main screen here. If I hit second, I'll show you what it should look like here. It should look like this. As you see here, it says 1var stats L1, comma, L2. The comma key is right here. So L1, comma, L2, and then you'll have 1var stats, and then you can go ahead and enter, and you'll get these same values. Okay, really quick, everybody type yes in the chat if you got these values you see on screen. The comma key is right here as well, right where my mouse is hovering over. I'm just circling it right now. Sorry. Yeah, so L1, comma, L2 there, Ujwal. So L1, comma, L2. Again, on your calculator, it should look just like this, okay? That's what it should look like. And just hit enter after that, yeah. Okay, cool. Camera, did you get set up there? Comma key is right here, right above the 7 key. It's not letting you use the comma key? I'm not sure what you're doing there, camera. I hope you followed the steps that I put out here. Again, you hit the stat key. No. So camera, take a look here. Watch the screen. Look at the screen here carefully, okay? You should have L1 here in your list, L2 in your frequency list, and then you can go down to calculate and hit enter. Since you have the newer style software, you don't have to worry about entering in the comma stuff. That's if you have older style software with your calculator. So if you have the newer style software, you don't have to worry about formatting. You'll get to this submenu here and it will do it for you. But I have to point both of them out because of the fact that some people have older style software and some people have newer style software. Okay. And again, you should get to this screen here. So make sure you get to this screen here and you should be okay. All right, so let's take a good look here at the values we get here specifically. Specifically, the values we get here, we get our mean here in this instance. Our mean here is 78.3 repeating. That's what you see up top here. We can also see our population and standard standard deviation and sample standard deviation. So our population standard deviation here is going to be, in this case, 13.1233. And our sample standard deviation here is going to be 13.3095. All right. We're going to be looking at some other values here, certainly, but again, this is how we can deal with group data to get the get that to work out first. Okay. So part of this other question, part of this other answer here, by the way, and I'll bring this back here for just a second. I need to write something down here. All right, so part of this here is like question 2. How do we find? So remember, find find the midpoint of each class and follow the steps to and basically and have list 1 L1 be the midpoints and L2 be the frequencies and use 1-bar stats. Okay. All right. Okay, very good. Any questions? Any questions about that? Any questions? No. Again, type no in the chat if you have no questions, or if you do have a question, let me know. No worries, Natty. You're good. We're gonna be taking a small break here anyway, so I just want to check if anybody has any questions before we take a break. A small break, so. All right, let's go ahead and take a short break here. We're gonna come back at 7:15. Let's do 7:15 here. None? Okay. 7:15 is when we will come back, and we'll have a shorter second half class here, but still, we'll get through with what we need to do here today. So we're in good shape. So 7:15, we come back. All right. So let's take our short break here. And let's get it. Yeah. All right. Good beans, and more good beans. Play some music, and we'll be right back. All right. Wait a few more minutes here, of course. Oh. Ooh. All right. All right. All right. All right. Let's get back to it, everybody. All righty. Hopefully everybody is okay, ready to go, doing things. We're doing bits. Let's do more bits. Let's make it extra nice. Good, good. Okay. Let's go back to our main screen here. Oh. All right. There we are. Okay. So, we are moving on here. We get started here with the second half of class. Before we move forward here, anybody else have any more additional questions before we move on? No? Hopefully everybody's back from the break. So there are no questions before we move on, then we'll go ahead and move forward. All right. Let's do it. Okay. So we're going to move on to question number 3 here. Now I am going to fill in the blanks here for some of these. I didn't prepare ahead of time because some of these are going to kind of intertwine together. Now, this is going to basically, I'll put it this way. We've done everything up to section 3.3. All right. So everything up to section 3.3 has been done and dusted. So these last set of questions here, section number 3 all the way down to number 9, are going to reflect sections 3, 4, and 3, 5, essentially. They're going to pretty much go together. Okay, so I just kind of want to point that out here. However, number 3 and 4 is a little bit separate than the rest. A little bit separate because it does have some significance later on as well. This has, actually, I should say, a lot of significance later on. So the first thing says, how do we find the z-score? Okay, so that's the first thing that we're going to describe here, is how do we go ahead and find the z-score here? So first of all, what is the z-score? Right? What is the z-score in terms of, say, okay, well, what exactly does that mean? Well, the z-score here basically is the number of standard deviations a data item is away from the mean. So what we've looked at here is we could try and figure out for every individual data item, we can figure out how many standard deviations that is away from the mean, given if we're given, say, the standard deviation of the data set and the mean, okay, of that same data set. All right. So there's a formula that definitely goes with this. Now, I do want to point one thing out. Actually, let's look at the formula first. Okay, let's do that first. And then we'll go ahead and take a look here at some examples and whatnot. So I'm actually going to put math type to this one here. So see this in action. All right. So the z-score here is specifically equal to the following. Now, I am actually, in this particular instance, I could write it in letters, and that would be nice. But in actuality, it's actually better to write it out in words because it actually makes a whole lot more sense. That in this. Okay. So here we have the z-score here is equal to the data item minus the mean, and we divide that by its respective standard deviation. Okay. So that is the formula that we have here. So I'll copy paste this formula here to our Word document here. All right, there we are. Okay, now I am going to put a note in relation to this here. Let's put a note here. One of the most important points as part of the z-score here is it is okay to get a negative z-score. A negative z-score just means it's below the mean. That particular data item is below the mean. And then essentially, if we talk about the negative, we talk about, again, positive z-score would be above the mean. I do want to put one notation here, not for the formula per se, but for z-score itself. As you will see different notations here for z-score, maybe given in a few different mannerisms. Actually, maybe two major mannerisms and then some other minor ones we'll look at later. But let's go ahead and go back here for just a sec. So z-score here specifically will look like this. So we could see z, or we also could see z z sub something, z sub data item. So you may see z sub data item. That's entirely plausible too. So there's a couple of different notations there, as you may see. You may see one of these two guys. So I just don't want you to be shocked to be like, where did this come from? Be like, no, there it is. It's right there. Okay. So you could data item here referencing, of course, the data item in question that we look over, depending on the problem. Okay. Now that's all nice and good. So that's pretty great. I'm sure that's that's not too hard. I think everybody can get along with that one. But let's take a good look here at some examples. All right, and we'll see how the z-score works. It's fairly straightforward. We'll look at that right now. Okay, so let's say we're given, let's do, so let's say, oops, not that. All right, all right, good. Let's say the mean here of a particular data set happens to be, go with 25, and let's say the standard deviation here, standard deviation is equal to 4. Okay, so we have a mean here of 25, and the standard deviation here is equal to 4. Let's say we want to find some z-scores here. Okay, so to first find the first z-score here, let's go with the z-score of 32. So what is the z-score of 32? Now again, the z-score of 32 is unique. Again, every data item has a unique z-score. Okay, so you're not going to find two data items that have the same exact z-score here. So we'll put that as a note here. Note, every data item has a unique z-score. All right, and that's because of the formula that we're given here. So in this particular case, we're going to have 32 minus 25, that's our mean, and we'll divide that by 4. Okay, so again, we could put that on the calculator there. And what do we get here as a decimal? We want a decimal for this here, by the way. We'll go to how many decimal places we want here? Check how many decimals. It's always particular about certain things. So we'll go to, it's not what I want to do. We'll go to 2 decimal places here. Where did I get the 32 from? I just made it up. I just made up the 32. That's just a random data item I just pulled out of thin air. So yeah, it's just a simple. It's just an example. I could literally put any number I want in there, and I would work with the formula. So let's go to 2 decimal places here. What do we get here for this particular case? This is going to be 7/4. Anybody got the decimal equivalent of 7 divided by 4 to 2 decimal places? 1.75. Okay, good. That's right. All right. So what does this represent? Let's talk about what this represents here. This specifically represents that the data item of 32 in this data set is 1.75 standard deviations above the mean. Okay. So now we have an actual, kind of value that's associated with that. Sure. Okay. Let's look at another one here. Let's look at, why don't you guys help me out with this one here? How about the z-score of, let's say the z-score of 20, we'll go 21.5. The z-score of 21.5. Again, out to 2 decimal places here. Can you tell me what the z-score of 21.5 is? I'll set it up. Again, 21.5 minus 25 divided by 4. What's that as a decimal there? Minus 0.88. Okay. Looks pretty close to being right there. I agree with that. Pretty much right. Let's see if other people got the same result. Did other people get negative 0.88? Okay, Natty got negative 0.875. Okay, so that does round to 0.88. That's right. That part is true. All right. So out to 2 decimal places here. I agree with both of those answers. And negative 0.88 is correct. Okay, so that's what we get here in this instance. So again, a negative value here, perfectly acceptable, perfectly valid at the end of the day. Doesn't mean that you exclude yourself just because you got a negative value. No, it's fine here underneath the z-score idea. Okay, so that's fine. So the question is, we have this z-score stuff going on here. It's not so hard to do now that you have a formula kind of associated with it. All right, so you're like, well, why the emphasis on such a simple aspect here? Well, not only does this allow us to look at any data item if we plugged it into a data set with given conditions, but we can also make one more association with the data items in the data set with this curve, with the z-scores here as our anchor. And that leads us to our next question that we talk about here is what does percentile mean? Okay, so let's talk about percentile here. All right. So let's put a little poll in the chat here. Negative values mean below the mean. That is correct, Joel. Yes. Negative values are below the mean. Positive values are above the mean. That means the data item is below the mean here for negative value, for negative z-score. And for positive z-score, that means that data item is above the mean. All right, so I put a simple poll up there on the chat. So take a look at the poll here. Did you take the ACT or SAT? Just a simple yes or no question there. Go ahead and vote in the poll up above. Okay, so there's the poll there. Did you take the ACT or SAT? All right, I don't know which one you guys did. If you did, great. Then mark yes. If you didn't, then say no. All right. You take the ACT or SAT. All right. All right, hopefully a pretty simple question there. If you didn't, then I'll be like, hell. It happens though. Some people haven't, so it's fair. Okay, so looks like everybody who voted here has taken the ACT or SAT. Now, really quick question for those of you in the chat here: did you guys do the ACT or did you do the SAT? I know things have changed quite a bit since I took mine. I don't know which one you guys took, so go ahead and post that in the chat there. If you took the ACT or SAT or both. Take the ACT, both, okay. Yeah, I know. If it's been a while, that's fine. It's not a big deal. SAT, okay. Okay. Now, Susan, I actually got a question for you since you took both. Which one did you find to be easier? Or were they both equally as difficult or not so difficult? I don't know. It just depends on your perspective. I'm actually legitimately curious. It's been ages since I actually have taken the test, so I don't know how it's been over the past exponential. You think the SAT was harder or easier? Easier? Okay. So I could tell you what I got. I did the ACT back in the day. Back in the day, I took 2 attempts at my ACT. So I had an ACT here. First ACT attempt was a 22. Second ACT attempt was a 25. That's what I got. I made a 3-point difference after going to a prep school for the testing stuff. So I won't say I was the best student. I was like a straight B student. I was like a B student for the most part. So like I would get A's here and there, but yeah. You had a bad score, that's fine. A bad score-ish. I mean, look, I know people who got stuff in the 30s or got like really good SAT score. I think it's what 2400s now the top part. Same again, average. Okay, yeah. I think SAT is what 2400 now instead of 1600. So you got like a yeah, I'd probably be hovering around like 1800 or maybe some are 1700. Maybe that's average or B average type of thing on the SAT. I think that's I think I think that's okay. I think. Yeah, actually, Cameron, that's actually a good point. If you're talking about GPAs, that's more of a weighted average, right? So you could actually use our concept we did today. The book does talk about weighted averages in terms of the GPA. Very straight. New to the States, took the ACT, got an 18. You know what? You know what, Ujwal? I'm gonna give you a pass for that, dude. Like, you're new to the States, and you know, if you had to take the ACT right away when you're new to the States, then the wording's maybe a little bit tough and stuff like that. 18 for a first go around when you came right to the States there. That's pretty good, actually. So, kudos to you on that. That's not so easy to just walk into and just, get an 18. So, definitely get a pass for that, man. I'm sure if you did it now, you know, yeah, okay. Well, if that's the, if you're there, then yeah. If you're spelling color honor, yeah, it's yeah, that's yeah, that's a big oof. That's a big oof since there's the two different spellings there. In fact, actually, Ujwal, to be honest with you, the English way or the American way of doing it, honestly, it should pretty much be the same thing. So an extra U shouldn't really be you shouldn't take off points because you wrote it the via the British system, which is what you grew up with before coming over here. So that doesn't make any sense. I think that's silly. So both have the same meaning. It's like if you spell program with an ME or with just an M, they're both correct. Center with an RE instead of an ER, they're both correct. So there's no difference, in my opinion. Yeah, it's pretty silly. Yeah, I agree with that. Yeah, and if you do that, it would mean this. You know what? There's no difference. The only difference is one letter, and it shouldn't determine your intelligence because you're using two different systems of spelling words that have the same exact meaning. It just means nothing. Now, I should tell you one thing here. Actually, I tell my students this all the time, but you guys should know this as well. That is in reference to GPAs. GPAs are actually rather interesting. Because if you do like your degree and you get your GPA and whatnot, um, one of the universal truths here that's true here, unless you're going into an education field, maybe, that all right. So basically, it kind of works like that. GPA is valid for 3 years after graduation. Then nobody cares. That is a fact. Because in those 3 years, what they expect you to have is the experience that's in the field that you actually took your major for or whatever. Then you should have the practical experience. So it's like, okay, GPA kind of gets your foot in the door a little bit, but in reality, yeah, you look at your job history, you look at your experience, and then basically that's it. So it's like, who cares if you got like a B? It's like, okay, what can you do on the job that can help the company, right? Nobody cares. Like, absolutely nobody cares. Can you do it, and can you do it well? That's if you're looking at it from a company perspective, that's all they generally care about. So they're like, okay, whatever. You got it, like whatever. So a lot of jobs do care about the experience because they would like to make the money right away rather than worry about how much book smarts that you actually got. Yeah, that's right. That's right, Ujwal. Absolutely. Some people have C's and they have good jobs because they can practically do it on their two hands. Yeah, Daddy, this is true. It's different than it was back then. Back then, your GPA would mean quite a bit once you walk out of college. But the problem is today is that there's more competition because there's more degrees. There's more people who have degrees, so there's more competition. They're like, okay, well, why does the GPA really matter if all that matters is what you can do after you get that piece of paper? Fine then. And that's all that matters at the end of the day. So perceptions have certainly changed over time. I will not disagree with that whatsoever. I think that's a very astute point. It's funny how things have worked out that way too. And that's the one thing about like college that I kind of get upset about is like, okay, if the grades don't matter because, it determines basically it's your ability that really determines if you're going to get that job or not. Um then exactly what are some of the classes that you do? Like the filler classes, what's the point of the filler classes if what you want to do is going to be um if what you want to do is, kind of separated from those filler classes. So that's the one thing there. Grades only matter for getting into college? I actually okay. I actually disagree with that camera. Okay, I agree with the scholarships part, but I disagree with the first part there. The reason why I say that is because I think that high school, now you guys can certainly correct me on this if I'm wrong about this. Um, but to high school today, I don't feel adequately prepares you to what happens in the real world. I think high school is very poor, makes you poorly equipped once you get into college. Like it really hasn't done the great it really hasn't done a very good job of preparing you for the real world. That's You're supposed to get like a big picture perspective about everything when you go through high school. 12 plus years worth of schooling and whatnot. But in reality, you don't get jack. You get nothing. Not nothing that's really worthwhile or again makes you a well-rounded person. I think that it should be, like if you go to other countries, like when I was in Japan, if you go to high school, yeah, high school is pretty tough in Japan, but it makes you like, I mean, there's other cultural things with Japan and stuff, but it makes you supposed to be the more well-rounded individual when you get out. So you can graduate and go to college, or you can get a job right after high school, and that's fine too. You know, yeah, I feel that high school shouldn't baby you. I think high school needs to be like its own. It's like, hey, you can go to college if you want a little bit more advanced education, or you can get your practical experience like the UK does, like internships or whatnot, right after high school is over. So, um, and you can be like an apprentice out in the real world and while getting, credit for classes or whatnot. So, and that'll get you closer to what you want. So, yeah, there's a lot of interesting ways for education, but I think we poorly equip students for getting ready for what should be the rest of your life. Your 1 year of high school felt, yeah. You know what, Ujwal, you're not the only person. You're definitely not the first to say that. I have a lot of transfer students from overseas, and they all said the same thing. Like when they came over here, they felt it was a cakewalk. And I'm saying, well, you spend so much money per student, and then if it's a cakewalk, then that's a problem. So, I mean, I know why it's a cakewalk, actually. It's not very hard to see if you're an educator, but it's very easy to see why it's a cakewalk for students. But then the consequence for what they're doing is basically diluting the education so far down that the student actually loses out at the end of the day. So let's not forget, everybody, the reason why they dilute the education for you is simply strictly because of the fact that they want to collect more money. They want to collect more money from you. If they want to collect more money from you, then basically they dilute everything down to its lowest common denominator, and then they essentially just let you on your way, saying that they did a great job. So I would say, like a lot of times, of like, you've heard of those people like get, it's just the material sometimes is a joke, and it's just like, what are you doing there if the material is a joke? So I want to see like real progress in high school. So that's my ideal vision. Will that happen? I don't know. Probably not. Probably not for a while unless somebody comes in there and does something about it. But yeah. In any case, oh yeah, what we were talking about. Right. Let's talk about what we're doing here. Okay. Let's talk about what we really wanted to talk about here. Okay. Now you've all taken the SATs and ACTs. Now, if you've gotten the results for your SATs and ACTs, one of the things that's important is on the actual score sheet that they mail to you or email to you, whatever the case may be, is they compare you with all the other students who actually took that same exact test at that same exact year. So if you did like really well in the math section, let's say you did the ACT and you got like a 30 on the math section or whatever, um, then they would say, okay, a 30, and they would take a look at the percentiles, like, oh, you're in the 95th percentile of people who took the math portion of the ACT. So that means that you did better than 95% of everybody else who took that same exact test in the math portion of the ACT, which is really, really good. In statistics, it works exactly the same way. In statistics, we say, well, what does percentile means? That means that that data item is basically going to be, and I better this correct here. I want to formalize this a little bit more appropriately. All right, the percentile, I should say the percentile is value such that I don't want to, you know what? I'm going to say it this way. I'm going to do it my way. All right. Says the data item is K% better than all other data items in the data set. That makes a whole lot more sense. I like that a lot better. So in a sense, again, that just kind of goes back to this. It's like, okay, you took a bunch of data items here. You're in the 95th percentile here. You did better than 95% of the students who had different scores and whatever. So that's just really, really outstanding. So what we want to look at here is we want to actually relate a z-scores here to the percentile here. We can actually see in a distribution, in a particular data set, what percentile would that be, that particular data item be, all right, given the z-score that we had found here. Okay, and the way we do that is there's actually things in the back. Let me see if I can find this one. This one's actually not as easy to find. So I always have an issue with this part here with the book. So give me a second here. Actually, want to, I bet. Okay. The e-text? Oh, it did. Okay, never mind. Never mind. But did what I asked it to do. It just came up very slow. Let's go to IA1. Okay. I gotta, like I said, what I'm trying to find for you here is not as easy as it. So there's certain tables in the book here that can relate z-scores to percentiles. I just gotta find it. It's kind of buried. It's like way far buried, so very, very annoying. But it is what it is. Okay, that is A11. It's kind of buried back. A12. So this is something that I want to show off here really quick. And this is like we will be working with normal distributions here, but there's a z-score here on the left-hand side, as you can see here. There's a z-score here on the left-hand side. This is the second decimal point here that we can get. So you could read this as like 0.72, and these are the percentiles that are associated with each of these respective z-scores. Now, what we're going to do is not use the table here, by the way. I just wanted to showcase that there is a definite link between percentiles and z-scores. We're going to use the calculator to find the actual percentiles here for sure. So when we do the test here, you're going to see that in action. But I do want to showcase is like, hey, yeah, this is actually a representation of an actual percentile. Okay, depending on what the z-score is actually going to be and where that would rank if you were to have a data set, with whatever. So um, that's there, but we'll use the calculator for the actual stuff there. All right. So I want to point that out there so that way, again, it's not surprising that we will definitely see this again when we do the actual tests, probability tests and whatnot, a little bit later on. All right. Any questions about that? Any questions? Okay. So this is where we're going to stop here for today. Okay. We're going to start up here at question 5. Now, questions 5 to 9 here. Like I said, this is going to be like most of the rest of 3.4 and 3.5. So this will be finished with chapter 3 after we finish off these questions. Okay. So that's going to be what's going to be on the docket here for next time. All right. And then once we're done with chapter 3, we're going to get into chapter 4. Just as a friendly reminder here that the first test will cover the first 4 chapters. So we're not quite there yet for the test. Um, chapter At the end of chapter 4, we're going to discuss the first exam. So once we get closer to that moment in time, we'll certainly talk about it then. All right. Well, in any case, I want to thank everybody for coming out here to the stream once again. Okay, all of you, thank you so very much for coming out today. You guys have been very wonderful to me. Thank you for coming out through the very boring times here. Yeah, if you have a question on the homework, feel free to ask. Oh yes, by the way, the homework there should be homework through a section 3.3 is what you should have if you want to keep up to date. We've just barely scratched 3.4, so you shouldn't start on that just yet. Even though we did talk about z-scores and percentiles, we're going to talk more about that for next time. So if you want to keep up with the homework there, section 3.3 is probably where you should stop. All right, Ms. Sandoval, you have a question there about the homework there. What question do you have there for me? Number 1 on 2.3? Okay. Take a look. Okay. All right, so let's go down the line here. All right. For those of you who are, oh my God, it's the same. Okay. All right. So let's take a look at the frequency polygon here. All right. Oh yeah, this question. Oh yeah. Okay. This one is kind of a pain that took us. All right. I won't lie, but we'll look at this carefully. I will say I know why. Okay, yeah. Okay, I know why this one is confusing because it's so poorly done based on what you see. So, without a doubt, I actually agree with you here for this. All right, but let's take a look at the class width here. I was like, this is not, yeah, you have an age of -5. I mean, I had no idea that people could be the age of -5. It's quite remarkable. I'm not gonna lie. But let's be the end was easy, but it's like, yeah, what? Yeah, you're right. You're right. Okay, so this graph here is a frequency polygon. It's just a really poorly drawn one. Because technically I would start at 0, but you can't because you have to have the proper class width. And so because you have to have the proper class width here, again, it has to maintain consistency. So technically you should start at 0. You could go 0 to 10 or 10 to 20, but they didn't decide not to do that. They decided to start at -5 to 5. So technically the class width here is 10, 10 age groups, but there's nobody who actually is -5 years old in this instance. So that's the class width there. So I know it doesn't make a whole lot of sense, but that's what they decided to do. Okay, so first we wanted to represent we want to represent how many people are represented in every class. So we have -5 to 5, we have 5 to 15, so we have 1, 2, 3. Okay, let me try that again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And looks like we got 11. So I want to say 11, or we have 10 here. Go with 11 to start with. I might be wrong about this one. Oh no, it's all right. Like I said, this is actually rather confusing even for me because of the poor thing there. All right, so we have a class width of 10, -5 to 5. That's 10 ages. 10 ages. 10 classes. We're not going to include this last one in here. So this one here is just another one. All right, so what's the midpoint of the first class? All right. So can you guys answer this one here? What's the midpoint of this first class, by the way? -5 to 5. What's the midpoint of that class? Yeah, so I'm thinking it's 0. I'm thinking it's 0 here because -5 to 5, we look at the midpoint between those two. It should be 0 there. At least I think so. Okay. So I want to see. All right. Yeah. All right. Think about this for a second. I need to think about what the question perspective is. I won't lie, this is one of those things that actually frustrates me about this program. So, okay, let me see. What do we want to look at here specifically? This is not going to be on the test. No, if I deem that the question is too difficult to do even for myself, I usually don't put it on the test, Natty. Actually, I should say I don't put it on the test because I don't think it'd be fair to you. So, I'm not about that life. Let me go here for. Let me check one thing here. Yeah, that's nice. Midpoint of the. Ah, that's right. That's right. Okay. Okay. This part here is actually really important. Recall that in a frequency polygon, the point is plotted above each of the class midpoints, and that the first and last points on the graph don't represent the class frequencies. Okay, that's true. Okay, so the point plotted is above each class midpoint. So that means that this one has to be 5. Yes. Okay, so this dot here represents 5. I think that's our answer here. Natty may be right about 10, so we'll see. Okay, 5 is the correct answer there. But okay, 5 is the correct answer. So based on that question help there, it says each point on the frequency polygon is going to be the midpoint of each class. Okay, according to what they drew in here. So the context matters here. So that's why 5 here is our answer. Hey, don't worry about it. The graph is misleading. Ujwal gets +1 point just for that. The lower limit of the first class is 0, and the upper limit of the first class. Okay, that's why it's 0 to 10 here. Okay, that's why we have this. So this is the midpoint here of 5, but it's technically between 0 and 10. And then 15 would be the midpoint. That'd be 10 to 20. Okay, and stuff like that. I'll check that one. The upper limit of the... Oh, are we doing 0 to 9? Let's see if it's 0 to 9. Probably right. Yep. Okay. So it'll be 0 to 9, 10 to 19. Okay, so our classes are going to look like that. Fair enough. Fair enough. The midpoint of the last class is okay. Can we dismiss this question from the homework? No. No. We get through it together. We move. It's fine. It's fine. We'll be fine. The last one here is 95, I believe. I know. We all can't get what we want all the time, but it's not terrible. The lower limit for the last class is 90, and the upper limit is 99. All right. So it goes 0 to 9, 10 to 19, 20 to 29, and so on and so forth. Okay. Which age group has the highest population? 40 to 49, because 45 is the midpoint of that class. Okay. Which age group has the lowest population? All right, I would say that'd be 90 to 99. Okay, so 90 to 99 here has the lowest population here. And as we see down here, midpoint. And then finally, which age group has 24 million people? So there's 24 right here on the left-hand side. That lines up with this. So it looks like 60 to 69. And we got it. All right, good stuff. All right, so it was a little tough there at the beginning because we just had to put it in the correct context. But once you know it's like 0 to 9, 10 to 19, and 20 to 29, it's not terrible. But I will say it is a poorly done graph, so I'm not a big fan of it. I'm probably not going to put this on the test. Or I should say, I'm not going to put this on the test, I should say. Let's be a little bit more transparent and clear what you mean by that. Yeah. So, Natty, the one thing that I want you to look at here is these dots that you see here represent the midpoints of each class, okay? They are not the actual, these are not the lower class limits or upper class limits. They represent the midpoint here. So what's the midpoint of a 5 here? 5 is the midpoint of the categories 0 to 9. That's basically what that represents. So what you have here is, let me go ahead and bring on this tool. Bring this here for just a moment. I'm going to bring this up. So what you actually have here in this instance is you have the categories of 0 to 9, 10 to 19, 20 to 29, and all the way down to 90 to 99. Okay? So it does go by tens, but the midpoint here for each class, because that's what each, in the frequency polygon that they drew, the midpoint here is 5, and the midpoint here is 15. And the midpoint here is going to be 25. All the way down to 95, where you see each one of these frequencies here in this instance. Okay? Does that make sense? 'Cause I hope that makes sense there. Just let me know if you have any other questions regarding that one. I can see why that could make you a little bit drive you crazy there. It's all good. All right, cool. Ah, no problem. You know I'm here to help. You ask me homework questions whenever, okay? I'm here to help you, all right? It's your time, and definitely want to be able to show that off if it's necessary. So, if you have any more homework questions, please feel free to ask, okay? All right, now that you got a good look at this, Natty, I'm pretty sure this time around it'll make a whole lot more sense. Okay, I promise you that. Thank you very much. You have a wonderful night. Okay. All right, everybody. Thank you so much here. Everybody else who's stuck around here just to kind of look at the homework question. If there are no more questions, if you do have a homework question, please you can bring it up now. Or if you don't have any, I want you everybody have a very wonderful and safe night here. Again, have yourself a wonderful weekend, everybody. Thank you so very much for coming out here to the stream once again. You all are super very kind. All right, I'm going to see you all back here on Monday, okay? I hope to see you all then. Have a wonderful weekend, everybody. All right, take it easy, and see you in a few days. All right, have a great one, everybody. All right, bye.